Welcome to the instructional resource, Getting Started with Fly to Learn, powered by X-Plane. In this video, we will learn to fly with a VOR navigation system. When driving in a car, navigation is fairly simple. Roads, trees, buildings, and signs are easily identifiable landmarks that assist drivers in navigating to their destination. We still have some landmarks when flying, but only when visible. Pilots need some other navigation system other than following a road while flying in low visibility conditions, such as in clouds or at night. You might think we could use a compass to navigate from airport to airport, and you wouldn't be far off. Pilots do use magnetic compasses to navigate, but they are aware of the compass's weakness. If a pilot were to only use a magnetic compass to navigate, then even a light wind could blow them off course. This effect may be small, but over an entire flight can add up to be significant. Let's try a simple example. This airplane will take off from an airport and fly to another airport due north. A crosswind blowing from west to east will gradually push the airplane off course, even though the airplane is always facing north. The airplane will end up significantly off course, and you won't even see the destination airport. We need some way to correct our course mid-flight. VOR, or Very High Frequency Omnidirectional Range, assists pilots by broadcasting a radio signal with navigation information. This radio is similar to the radio in your car, but instead of music, it has information about your location with respect to the station's location. VOR will allow us to make corrections mid-flight. VOR radio stations broadcast 360 radials, one for each degree in a circle. Your location will determine the value, or radial, that you will receive from the station. Note that this value, and all compass values we use while navigating, are magnetic values. The value we read off a magnetic compass may not align perfectly with true values. Depending on your location on Earth, magnetic and true compass values may be significantly different. VOR stations do not provide any information about how far you are from the station, only the directional value, or radial. The VOR signal cannot be received while the aircraft is on the ground or at low altitudes. The receiver in the aircraft must be in line of sight to the station to receive a VOR signal. If you are due north of the station, you will receive a value of 0, or 360 degrees from the station. If you are due east of the station, you will receive a value of 90 degrees from the station. If you are due south of the station, you will receive a value of 180 degrees from the station. If you are due west of the station, you will receive a value of 270 degrees from the station. The value, or radial, you receive from the station is not related to the aircraft heading. The aircraft could be facing any direction and still receive the same value. VOR signals are tuned as from and to. There is 180 degrees difference between a to and from signal. It is like when you walk to an object, you could turn completely around 180 degrees and you would be walking from an object. So far, we've only looked at the value from a VOR radio station. If we were to use a from value to navigate, then we would travel away from the station. Most of the time, we will be using a to value because we want to fly towards the VOR station. If we are due east of a station, the VOR from radial will be 90 degrees. To get the to value, add 180 degrees for a value of 270 degrees, which is west. If we are due east of the VOR station and we fly west, we will be flying toward the station. Whenever tuning a navigation radio to find the radial, it is crucial to know if this is a to or a from value. Let's try a flight using VOR navigation. We will be flying a Cessna 172 from Colorado Springs Municipal Airport, which is known by its identifier as KCAUS, to Denver International Airport with the identifier DEN. Start by selecting the Colorado Springs Municipal Airport. Select Runway 30. Before taking off, note that the altimeter indicates about 6,200 feet. The Colorado Springs Airport is already well above sea level. This means that the aircraft is at 6,200 feet MSL, which stands for mean sea level, while it is 0 feet AGL, which means above ground level. To take off, release the brakes. Then push the throttle all the way in. Wait until the airspeed indicates 70 knots, then pitch up. VOR navigation doesn't work at low altitudes, so let's climb to at least 1,000 feet AGL, or above ground level, before preparing the VOR to navigate. Because we took off at 6,200 feet, we will need to climb until the altimeter indicates 7,200 feet. Now that we've climbed sufficiently high, let's tune in our navigation radio. We will need to look up the frequency of the VOR on our sectional map. Select Location. Then Local Map. Make sure that Sectional is selected. Find the Denver Airport, also known as DEN, north of Colorado Springs. The VOR radio frequency is 117.90. Select the X to return to flying. Find Navigation 1. The aircraft has 2 navigation radios installed. This provides a backup if one radio fails and also allows a pilot to triangulate the position of the aircraft. Triangulation is an advanced navigation skill that involved pilots using 2 VOR stations to determine their exact location. Triangulation is beyond the scope of this instructional resource. There are 2 sizes of cursor selectors you can use to tune the radio. We are tuning to 117.90. The next step is to use the OBS knob on the Navigation 1 instrument to rotate the compass. Rotate the OBS knob until the white line is centered and the FR flag is white. We will be near the 175 degree from radial. We want to fly towards the VOR station, so adjust the OBS knob until the white line is centered and the 2 flag is white. We should be near the 355-2 radial, which is rotated 180 degrees compared to the from radial. If we fly with a heading equal to the 2 radial, we will be flying towards the VOR station. Let's turn the aircraft to the heading 355 degrees. Now we fly in this heading for the required distance. Denver is 62 nautical miles from Colorado Springs, so at our airspeed of about 110 knots, it should take just over half an hour. If the white bar moves from center, then you have drifted off course. We will need to retune Navigation 1 to find our new heading. Use the OBS knob to move the white line to the center while the 2 flag is white. This is our new heading. Turn the aircraft so that the heading matches the VOR instrument. Let's keep flying. Eventually, we'll see the Denver airport ahead of us. Congratulations, you've accomplished your first navigation flight. Now try your first cross-country solo. Start on runway 30 at the Colorado Spring Municipal Airport, KCOS, and navigate to Pueblo Memorial Airport. You'll have to look up the VOR radio frequency on the sectional map.